Multiplying and dividing rational expressions. Our objective is to multiply and divide rational expressions. Why learn this? You can multiply rational expressions to determine the probabilities of winning prizes at carnivals. Let's start with multiplying rational expressions. You have if A, B, C, and D are non-zero polynomials, then if you have A over B times C over D, that's going to be equivalent to A times C over B times D. Let's look at a few examples. So we have the quantity A plus 3 divided by 2 times the quantity 6 times the quantity 3A plus 9. Notice how you have a binomial. You can't do anything with the A plus 3, but we can factor using greatest common factor for the 3A plus 9. So we're going to factor out a 3, leaving us with A plus 3. And since we're multiplying, we can cross-reduce. We have this now as one clump, and that is one clump, so therefore we can cross those off. You can also cross-reduce your 2 and your 6, giving you 3 and 1. So on the top, we're just left with a 3, and on the bottom, we're just left with a 3, giving us 1. Let's try another one. So we have 4 monomials all being divided and multiplied. So what we can do is we can simply start cross-reducing. We don't have to factor first because there's no binomial or trinomial to have to worry about. So we can start with our numbers or the variables. Either way is fine. I like to start with the numbers. So if we have 12 and 3, we can cross-reduce, and that 3 becomes a 1, and the 12 will become a 4. If we cross-reduce our 5 and our 15, 5 becomes 1, and 15 becomes 3. So numerically, we end up with 12 as our numerator and 1 in our denominator. And now we can do our variables. So let's start with letter A. So we have A squared on the top and an A on the bottom. So when we divide like bases, we subtract their exponents. So this is like A to the first. So 2 minus 1 is 1. So we're left with an A on the top. Now let's do our B's. So we have B to the third and B, giving us a total of B to the fourth on the top. And we have a B squared on the bottom. So 4 minus 2 is 2. So we're left with a B squared. And now we have our C's. We have C squared on the top, and we have C to the first and C to the first on the bottom. So C to the second minus C to the second, divided by C to the second will still give us just 1, because you're not left with anything. So when we're all said and done, we end up with 12AB squared. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. So let's step it up a notch. So now we're going to try multiplying a rational expression by a polynomial. So if you were to take any whole number and try to make it a fraction, you would put it over 1. The same idea follows when you're dealing with a polynomial. So you're going to have the x squared plus 8x plus 15, and that whole trinomial is going to sit over 1. And you're going to multiply that by your 4 over 2x plus 6. So now, we can't just start crossing things off. Like we can't cross a 2 and an 8 off or anything like that. Notice how there's these plus or minus signs in here? That means you're going to have to factor. So we can start with this one here. So we want two numbers that will multiply to give us 15, but when we add them will give us 8. So that would be 3 and 5. So we factor. And then we can also factor this 2x plus 6. There's a greatest common factor of 2, so we pull out a 2 and we're left with x plus 3. Now you should notice that there are two things that are the same. So we have x plus 3 and x plus 3. So this leaves us with 4 and then x plus 5 as our numerator and 2 times 1, or 2, as our denominator. So we can simplify our fraction here. 4 halves is the same as saying 2. So this is equal to 2 times x plus 5. And then if we distribute the 2, we'd end up with 2x plus 10. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. There are two methods for simplifying rational expressions. You can simplify first by dividing out common factors and then multiply the remaining factors. You could also multiply first, then simplify. Using either method will result in the same answer. So let's take a look. So we have this 4d to the third plus 4d over 16f times 2f over 7d squared f plus 7f. So method 1, simplify first. So what we're going to do is we're going to factor out a common factor out of our 4d to the third plus 4d and our 7d squared f plus 7f. Now we can start cross-reducing. So we can get rid of our 2d plus 1. We can also reduce our 16f and our 2f. And we can reduce our 4. So now that everything is all nice and reduced, we can then multiply what we have left. So if we multiply what we have left, we only have a d as our numerator, and it looks like all we've got is our 7f and a 2, so d over 14f. Well, what about method 2? You could multiply first. So if we're going to multiply first, remember we want to distribute our monomial across our binomials. So when we do that, we end up with that lovely piece of work. From there, you can divide out your common factors, and in the end, you still end up with d over 14 times f. Let's try one from scratch. For this one, you can use either method, whichever one you prefer. But when you return to the video, an answer will be revealed. And there you have it. Now let's move on to dividing. The rules for dividing rational expressions are the same as the rules for dividing fractions. To divide by a rational expression, multiply by its reciprocal. So if we have a over b divided by c over d, that's going to be equivalent to a over b times d over c, which then gives us a d over b c. Let's practice. So we have 1 over x, and we want to multiply by the reciprocal. So 1 divided by x times, and then we're going to go 2x over x minus 2. So if we combine these, we end up with 2x over x times the quantity x minus 2. And then we can reduce our x and our x will cancel out and become 1. So we're just left with 2 over x minus 2. Let's try another one. So we have x squared minus 2x over x. We're going to multiply that by the reciprocal. So that's going to be x squared plus 2x plus 1 over 2 minus x. Notice how once you multiply by the reciprocal, it looks exactly like what we were just doing. All division has is an extra step. You have to make it a multiplication sign and then flip your next fraction. And then follow your normal rules for multiplying. So if you see a bunch of binomials, it might be good to factor first. So let's do so. So for this one, we can factor out an x, leaving us with x minus 2. And then for this one, we would like to go forth and see if we have two numbers that multiply to give us 1, but when we add, they give us 2. Well, only one possibility for that. That would be a 1 and a 1. Notice how this x minus 2 and this 2 minus x are exact opposites of each other. Recall back, when that happened, we could multiply by negative 1, and it would flip it. So if we have negative 1, and then we'd have x minus 2. Because a negative times a negative is a positive. So by keeping our negative 1 and then flipping it, you're essentially having a negative times a negative. Only difference is you might not necessarily see that because of the fact that you cross off one of the pieces. So the negative kind of stays behind. So let's start cross-reducing. So our x minus 2's can cross-reduce. We can reduce our x's. And now we're just left with x plus 1 times x plus 1, all divided by a negative 1. Well, we can rewrite this to say negative x plus 1 squared. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. So now let's try a probability application. Marty is playing a carnival game. He needs to pick 2 items out of a bag without looking. The bag has red and blue items. There are 3 more red items than blue items. Write and simplify an expression that represents the probability that Marty will pick 2 blue items without replacing them first. We're going to let x be the number of blue items, so that way we have a consistent variable here. Therefore, our blue is x. Now, it's stated that there are 3 more red than blue. So that means red is going to be whatever blue is plus 3. And in total, if we were to combine these, we'd have 2x plus 3. Okay, so the probability of picking a blue item and then another blue item is the product of the probabilities of the individual events. This should sound kind of familiar. Only difference is, in the past, we had actually numerical values for these instead of values with x's inside of them. So, the probability of blue, then blue. So, the probability of blue the first time is x over 2x plus 3. Blue out of the total. But they're not putting a blue back without replacing them. So that means there's 1 less blue if they've already taken 1. And then you have 2x plus 3, and there's 1 less out of the total. So now you have x over 2x plus 3 times x minus 1 over 2x plus 2. Now this looks like what we've been doing so far. So let's continue this problem. What is the probability that Marty picks 2 blue items if there are 10 blue items in the bag before his first pick? So we're going to use the probability of picking 2 blue items. Since x represents the number of blue items, we're going to substitute 10 for x. And then we simplify. So the probability of picking 2 blue items, if there are 10 blue items in the bag before the first pick, is approximately 0.18. And that ends our video lesson on multiplying and dividing rational expressions.